In this unit, we have one major equation, and that is Q equals M times C times delta T. So let's break down each of these parts. The Q stands for heat. I know it doesn't make much sense, but Q is heat. That's the heat absorbed or released. If the heat is absorbed, it means that heat is gained and the total energy of the material increases. So Q is positive. So Q, the heat, is a type of thermal energy. It's a type of energy, we call it thermal energy, or just heat. It's the amount of energy that we're adding to or taking away from a substance. So if it's absorbed, that means Q is positive. If it's released, if it releases thermal energy, that means Q, the heat, is negative. Kind of like if we're thinking about your bank account, if you're adding money to your bank account, you're absorbing some money, you have a positive change in your bank account, more money. If you're releasing money, you're getting rid of money, spending money, then you have a negative change in your bank account. So absorbing Q, if Q is positive, that means you're increasing the total energy of the substance. And if you're releasing Q, if your heat is negative, that means you're getting rid of some of the energy of your substance. So heat is a form of energy, thermal energy. It's really energy transfer. And so the unit must be, and I know you guys all said it, the unit is joules, which is a capital J. The symbol is a capital J. Alright, so that's on the left side of the equation. The Q is the amount of heat being absorbed or released. Alright, so then we have M. M is our good friend mass. We've seen lots of mass. It's the mass of the material, and its units are kilograms, of course. Symbol kg. Alright, that's mass, not to be confused with weight. Mass is measured in kilograms. After that, we've got a little c. The c is a fairly new idea for us in this unit. It's called specific heat. And so it's not the same thing as heat, even though it sounds like it's called specific heat. And basically, it's the amount of energy needed to increase the temperature of your substance, or rather of 1 kilogram of your material, your substance, by 1 degree Celsius, or 1 Kelvin. In other words, it's how much energy you need to put in order to make something's temperature rise. The specific heat depends on what material you're using. So C depends on your material. And a lot of times the value can just be looked up. Sometimes we look up the value in a table. And sometimes we solve for it using this equation. Alright, so that's the C there, specific heat. Not the same thing as heat. It's the amount of energy, the amount of heat you need to increase the temperature by 1 degree Celsius if you got 1 kilogram of the substance. Okay. Then our last guy here is delta T, and that's a capital T. The capital T stands for temperature. So it's a change in temperature, which is the final temperature minus the initial or starting temperature. So if we know what the temperature is going to be at the end, and we know what the temperature is at the beginning, then we take the ending temperature minus the beginning temperature. The change will be positive. Delta T is positive if the temperature is rising, and delta T is negative if the temperature is falling. Okay, so that means if we start at one temperature and we go to a higher temperature, it's going to be delta T of positive, and if we start at a temperature and we fall to a lower temperature, delta T is going to be negative.